Hi, good morning students. Welcome back for the session 3, data representation. In the previous session we discussed about some numbering system and also how to convert some numbering system through any type of the numbering system, positional numbering system to its decimal numbering system. Just a brief conversions ideas we learned in the last 2 sessions, dear students. And also we discussed about some different positional numbering systems like decimal numbering system, octal numbering system, binary numbering system, as well as hexadecimal numbering system. So by all these positional numbering system, one common thing what we have to understand means any type of the numbering system computer will accept through binary because it have a chance to convert that number into any types of the forms. Like that, yesterday we discussed some decimal numbering system, that is a base, a radix 10, the total number of decimal numbering system 0 to 9. Like that, if I coming to the second type of the numbering system, binary, there the radix is 2 and the two numbers are 0 and 1. Like that, octal numbering systems are having a radix of 8, 0 to 7 are the total numbers, what the digits we have. Like that, hexadecimal numbers we discussed, in that hexadecimal numbering system, the radix is 16, the base values what we discussed, that is 0 to 15. After 9, we are given some character representation from 10 to 15, like A is a 10, B 11, C 12, like that, so on 15 F. So these common things we discussed in the previous 2 sessions, dear students. Today, somewhat we are going in depth of this concept for conversion types. How to convert decimal to binary conversion. Of course, we have some methods. Very easily we have a chance to convert that decimal number into binary numbering system. I will show that also. But this is a preferred method how we want to convert decimal to a binary number system. So here they are given some steps. One by one, once I will read all these steps, just you analyze these steps. Now based on these steps, we will apply one problem. After that, you will coming to know how to convert the decimal numbering system to binary. So in that, the first method, that is decimal to binary conversion. In that, step number 1 says divide the given decimal number divided by 2. Whatever the decimal number we want to convert, that number divided by 2 we have to make, because divided by 2, why we are using the divided by 2? We are using numbering system that is a binary. So conversions of decimal number into binary means we have to convert that into single forms. 0 to 0 and 1 reminders should become like that. That's why whatever the number they will give, we have to convert that number into, divided by that number into 2. Then after that, in second step, note the quotient and remainder. Note the quotient and remainder. Step number 3, repeat the step number 1 and step number 2 until the quotient becomes 0. Until the quotient becomes 0, again and again we have to repeat all the steps 1 and 2, whatever the steps, iterations it will happen. So for that we are doing that simple calculation. Then last final step, we will call the first remainder what we will get, that is LSB, and the last remainder is MSB. You in your mind you get one question, what is LSB and what is MSB? I will show with an example. LSB, if you want abbreviate, least significant bit. MSB, most significant bit. Like that, and note the remainder from MSB to LSB, very important. MSB to LSB, from most significant bit to least significant bit, what we will get. Like that, we want to calculate one number that should be into one binary number. I will show with one small example, dear students. Based on this example, you coming to know how to convert one decimal numbering system into binary numbering system. I will consider one example to prove this decimal conversion to binary conversion. This is one example, decimal number. We are accepting one number, that is 53. Now apply these common rules for this type of the number. What the step says, step number 1 says, divide the given decimal number by 2. Okay, I will consider this one. Anyhow, in simple mathematical step, you know this step in previous years. 53 divided by 2. Okay, then what will be the step number 2? Note the quotient and the remainder. Okay, I will continue that one. 2 2s are 4. Okay, 1 will be the remainder. 13, 2 6 are 12. So the remainder should be 1. Like that, I want to continue. Repeat step number 1 and step number 2 until quotient becomes 0. Until this quotient becomes 0, I want to continue. So we concentrate on this one. 2 1s are 2, 2 3s are 6. So the remainder is 0. Then 2 6s are 12. The remainder is 1. 2 3s are 6. The remainder is 0. 2 1s are 2. The remainder is 1. Then that should be, quotient should be 0. The remainder is 1. So then what will be the LSB? And now I did 3 steps. So repeat step number 1 and step number 2 until the quotient becomes 0. Now I make the quotient becomes 0. So now I will consider here when they are given one step. The first remainder is LSB. Then where is the first remainder? See here, this will be the first remainder, LSB, least significant bit. And the last one should be MSB. Last one means this one, MSB, isn't it? Like that, now we have to take the answer by this format, MSB to LSB. Observe this one, MSB to LSB. MSB to LSB means this way. This is the method how I will consider. See here, 1 1 0 1 0 1 will be the answer. See here, like that we have to write 53 of decimal, that should be converted into binary number. Okay, 1 1 0 1 0 1 1 1 0 1 0 1. This should be one binary number. See, 53 is a decimal number, 53 is a decimal number. Now 110101 will be the binary number. Whether this binary number is right or wrong, we don't know, right? Better you cross check this. Don't believe blindly. So you cross check this binary number whether this is 53 or not. How? see, yesterday we discussed about binary numbering systems. Take consider with the binary numbering systems like this. This should be 1, 2, 4, 8, 16, 32. Now just you add all the ones where you will get. Ones, neglect the 0 parts of the decimal number. Where 1 is there, you just add those numbers. 32 plus 16, okay, 32, okay, 6 plus 2, 8, 3 plus 1, 4, 48. 48 plus 4, 52, 52 plus 1, 53, like that. Like that. See here, 1 plus 4 plus 16 plus 32, definitely you will get 53. So by this topic, what you are understanding? Yes, we have a chance to convert a decimal number into binary number. Like this, we have one method, that is a conversion type. Then cross-check what you will get the answer by the table. Yesterday we shown that table also, that is 1, 2, 4, 8, 16, 32, 64, multiples of 2 what you will get, because that is a binary number. Just make that one table, apply that where the 1 is there, just add that number, definitely you will get one decimal value. So this is the how one decimal number, if they are given decimal number, this is a method to convert the decimal number into binary number. But sometimes they may given some fractions. Some fractions they given 53.09. Then how to convert that 09 into binary number? I will show in the next example. So after decimal conversion to binary number, now decimal fractions to binary conversion. The last example we discussed for the normal decimal number, but now this is an example decimal fraction number. Now we have to convert that into binary. For that we have to follow some steps. What are all the steps? There anyhow we are dividing the given decimal number by 2, but here when we are going for the fraction, automatically the steps will changes. What are all the steps will changes? What are the methods to convert the fraction number into binary number? See here. Multiple the fraction number, decimal number, and note the carry and the product. See, when we are converting normal decimal number, there we are using dividing method. But here now we are using fraction numbers, that's why we are using multiply method. Don't get confused here. For the normal decimal number, that is dividing method, dividing by 2. But here this is a fraction decimal, so we are multiplying by 2. Multiplying, that is a multiply with the 2, multiply the 2 with the fraction number, that is what we called as decimal fraction conversion into binary conversion. Then step 2 says, repeat step 1 until the fraction product becomes 0. Until the fraction product becomes 0 means, I will show with an example. Whatever the product we have to convert that into makes into 0. Then that step will be stopped. Like that we have to follow. Then the first carry is MSB and the last carry should be LSB. Here also we have to follow the same method, MSB to LSB. Then how to convert one example? Then I will consider the same best example, 0.3125 decimal fraction number into its binary number. We are using some a table method here. Write down this table method. Based on this method, now we are able to convert that fraction decimal into binary. If I want to consider this example 0.3125 of base 10, that I want to convert that into binary number. So for this, now I want one table. Now I am considering one table. What the table says, see here, the heading multiply by 2 will be the one heading. What the number they are given, we have to multiply by 2, and we have need one more column, that is a carry, and second one is product. See here, read the step number 1. Multiply the given fraction number by 2, note the carry and product. Note the carry and product. Then repeat the step 1 until the fraction product becomes 0. See here, until the fraction product becomes 0, there we have to up to multiply by 2. Then first carry will be MSB and the last carry will be LSB. Write down the MSB to LSB form. How that will come? I will show one example. See here, the given number is 0.3125. Consider that 0.3125 multiply by 2. Then what will be the answer you will get for that one? 0.3125 into 2 means 0.3125 into 2 means that is 0.625. Answer is 0.625. See here, now I will consider 0 as will be the carry. Where is 0? Check the answer. Before decimal, what the number you are getting, that should be the carry. So 0, okay. Then after that product, that whole the product, what you will get? 0.625. 0.625 will be the product. I will consider carry before decimal, what the number I will get. Okay. Then second step, I will consider 0.625 will be the input. Then what will be the answer you will get? See here, 0.625 into 2. What is an answer? The answer is 1.25. 1.25. So here 1 will be the carry. That's why this 1 I will wrote here. And what the remaining number? If the carry will be 1, then after the product is, that is 0.25. Correct? Then after the 0.25, now I will consider that 0.25 will be multiplied by 2. Then what will be the answer? That is 0.25 into 2, that is equals to 0.50 will be the answer. Then what is the carry here? When the 0.25 multiplied by 2, 0.25 multiplied by 2, carry is 0. See, the carry is 0. This should be the 0. Then what will be the number? The product, that is 0.50. Correct? Then if I consider 0.50 is multiplied by 2, then 0.50 into 2, that is equals to 0.50 into 2 means answer you will get to, that is a 1. 0.50 into 2, that is 1. So hence the carry will be 1 only. If the carry will 1, then the product should becomes 0. Hence the product is 0. Read the step number 3. First repeat the step 1 and until the fraction product becomes 0, there up to that you have to multiply. So here we have to start and read the step, last step. The first carry is MSB. This is MSB. The last carry will be LSB. Write the answer in the form of MSB to LSB. Remember this arrow mark whenever multiplying, that is down to earth. Whenever dividing, that is upwards. So whenever multiply, 0, 1, 0, 1 will be the answer. How to write that answer? See here, I will write here. So the method of writing answer for the 0.3125, that is, see here, 0.0101 of binary number. This is the answer. Check the right side. 0 and 1, only the numbers are there, 0 and 1. But check the left side, 3, 1, 2, 5, all the numbers are there. This is what conversion of decimal fraction to binary, normal binary. This is the method of converting decimal fraction to binary conversion. So consider like that some examples by own. Apply your own ideas for the conversions. Whether your answer is right or wrong, you cross check. Like that you follow some different methods of the conversions. There you will get exact answers for the conversions of the decimal number 2. Then in the next step, we are going for conversion of binary to decimal, the reverse format. How to convert that one, that we will see in this particular session. Next step, binary to decimal conversion. We already in the introduction class itself, I shown already how to convert one binary number into a decimal number. The same problem I am showing once again. Okay. Binary to decimal conversion, the step number 1, multiply each bit of the binary number by its positional weight. By its positional weight. Add all the products, whatever the values you will get, you just add all the products, then you will get one particular decimal value. Then now I will consider one example. 11011.101 will be one binary number. Now I will convert this binary number into decimal number. See, very simple method I am telling. Count the numbers, total numbers, how many numbers of the digits they are given. Total almost 8 numbers of the digits are given. Consider the 8 columns. First of all, you make the 8 columns. Then just you fill with the multiples of the 2 by its weight. How? See here. That is, consider 0, 1, 2, 3, 4. Multiply that its binary number. 2 to the power of 4. 2 will be the radix because it is a binary number. 2 to the power of 4. Then like that we have to go as moves on. 2 to the power of 3. 2 to the power of 2. 2 to the power of 1. 2 to the power of 0. 2 to the power of, after decimal, this is minus 1. 2 to the power of minus 2. 2 to the power of minus 3. Then apply what the digits they are given. Just apply the bits or digits. 1, 1, 0, 1, 1.101. Now you just multiply the value. Okay. 2 to the power of 4 means that is 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 8, 8 2s are 16. Okay, like that. 2 to the power of 3, 8. 2 to the power of 2, 4. 2 to the power of 1, 2. 2 to the power of 0, 1. Because anything to the power of 0, that is equals to 1. 2 to the power of minus 1. See here. 2 to the power of minus 1 is equals to 1 divided by 2 to the power of 1. Because x to the power of minus n is equals to 1 divided by x to the power of n. Based on this formula, 2 to the power of minus 1 is equals to 1 divided by 2 to the power of 1. 1 divided by 2 means that is 0.5. Like the 2 to the power of minus 2. 2 to the power of minus 2 is equals to 1 divided by 2 to the power of plus 2. So 2 to the power of plus 2 means 4. 1 divided by 4 means 0.25. Like that, 2 to the power of 3 means 2 to the power of minus 3 is equals to 2 to the power of plus 3. 2 to the power of plus 3 means 1 divided by 8. 1 divided by 8 means that is 0.125. 0.125. So this is the simple method how we are converting a normal binary number into its decimal number. Just now add. Okay. Wherever 1 is there, you just multiply the number. 16 into 1, that is 16, plus 8 into 1, 8, plus 4 into 0, 0, plus 2 into 1, 2, plus 1 into 1, that is 1, 0.5 into 1, that should be, after this one you consider 0.5 into 1, that is 1, plus 0.25 into 0, 0, plus 0.125 into 1, 0.125, 0.125 plus 1, that is 0.75, 6 to 5. So 16 plus 8. So 16 plus 8, 10 plus 26 plus 1, 27.625 will be the answer. So this will be the 1 decimal conversion. So like this, we are able to convert any type of the number into binary to decimal numbering conversion system. Very simple method. Follow, you consider some binary numbers and apply the same methods, then you will get the conversions of the numbering system, binary to decimal numbering converting system. After this, we are going to go one more method of the conversion, that is octal numbering system. In the next session, we are going to discuss about that is octal numbering system.